Chapter 2.2 is models and applications. We're just going to be going over some problem solving with linear equations. So essentially we're going to be given a word problem and we're going to have to create our own equations and solve them. And we might have to know certain formulas such as the area of a rectangle, the perimeter of a rectangle, or some geometric formulas such as those. So let's just see three examples here. So the first one, the length of a rectangular football field is 20 feet more than the width. If the perimeter of the field is 1,040 feet, what are its dimensions? And then we're going to include units in our answer. So to start this off here, it's always a good idea to draw a picture. So here's just a rectangular football field, so it is a rectangle. And then we're going to have two units of measurement since it's a rectangle, length and width. Of course, opposite sides are the same, but you don't have to label them if you don't want to. So we are told that the length, which is L, is 200 feet more than the width. That means we can rewrite L as 200 plus W. So we know L is 200 plus W. We're also told that the perimeter of the field is 1,040 feet, and we want to figure out the dimensions of the football field. We want to find W and L. So to start this off, let's go ahead and actually write down the perimeter formula for a rectangle. So remember, perimeter just means you add up all of the sides of whatever shape it is. So perimeter is going to be L plus W plus another L plus another W. So L plus W plus W, or 2L plus 2W. So that's just always the perimeter of a rectangle. Perimeter equals 2L plus 2W, or whatever variables you wanted to use. And then what we can do here is we can actually plug in. We can plug in that the perimeter is 1,040. And then we can also plug in that the length is 200 plus W. So we just replaced perimeter with the number that it actually is. And then we replaced L in terms of W. The reason why that's important is now we just created a linear equation, and this allows us to solve this for W. We have one equation, one variable. We can solve this for W by first distributing that 2 on the right-hand side. So we end up getting 400 plus 2W when we distribute. And then linear equation, we want to get all of the variables on one side, everything else on the other side. So we can subtract 400 on both sides. 1,040 minus 400 is 640. And then we can just combine like terms. 2W plus 2W is 4W. And to finish solving this for W, all we have to do is divide both sides by 4. 640 divided by 4, we get 160. So it said that the units are in feet. So this is going to be 160 feet. And it said that we want to find the dimensions. That means we want L and W. We already have W. Now we go ahead and find L. And we can use this little formula that we created for L. L is 200 plus W. The reason why that comes in handy is because we just found that W is 160. So we can just plug that in. So 200 plus W, 200 plus 160. That gives us 360 feet. So we have the dimensions of the field are 160 feet by 360 feet. Okay, so let's see another one that's pretty similar. So the length of a rectangular garden is 50 feet more than the width. If the perimeter of the garden is 300 feet, what are the garden's dimensions? Include units of measure in your answer. So once again, good idea to draw a picture. And also, once again, this is a rectangle. So just always keep in mind what shape that they're telling you whatever it is, the garden is in this case. It's a rectangle, and we're dealing with width and length once again. So we can call this the width, we can call this the length, and we're told that the length is 50 feet more than the width. So once again, we're going to rewrite length in terms of the width. Length equals 50 plus W, 50 feet more than the width. And we're also told, once again, pretty similar question, that the perimeter is 300 feet. So since we're dealing with perimeter, we're going to write down the perimeter formula for a rectangle, which once again is always the same thing. Perimeter is 2L plus 2W, just adding all of the sides together. And we can go ahead and we could substitute in the 300 into the perimeter variable P. And then we can also substitute in, instead of L, we can write 50 plus W. So we can still have that plus 2W at the end. So just like the one that we just did, we just created a linear equation in terms of one variable, so we can solve this for W. So we're going to start by distributing the 2 on the right-hand side and get 100 plus 2W, and then plus that 2W at the end. Pretty similar to last time, we can subtract 100 on both sides to get all of the constants on the left, keep the variables on the right. So 300 minus 100 is 200. And then we have 2W plus 2W gives us 4W. And then divide both sides by 4 to solve for W. 200 divided by 4 gives us 50. So once again, we want the dimensions. That means we want all of the variables for the sides of the rectangle. So we want W and L. And then this is in feet once again. So we just found that W, the width, is 50 feet, but we still need the other dimension, L. We know L is 50 plus W, so that's going to be 50 plus 50, plugging in the value for W that we just found, which means the length is 100 feet. So really similar to the one that we just did, just a different word problem with different numbers, but we do it the same exact way. So let's take a look at one more here where it's going to be kind of similar again, but just a little bit more difficult. So the length of a new rectangular playing field is 4 yards longer than quadruple the width. So the length of a rectangle, so it's rectangle again, we're dealing with the rectangular shape again. The length is 4 yards longer than quadruple the width. And we're dealing with perimeter once again. The perimeter of the rectangular playing field is 508 yards. What are the dimensions? And include units in your answer. So let's go ahead and draw a shape out again. Rectangle, we're dealing with length and width, W and L, or whatever variables you want to use for length and width. And we are told that the length is 4 yards longer than quadruple the width. So that means the length is 4 plus, quadruple means 4 times. So it's 4 yards longer than 4 times the width. So L equals 4 plus 4W. So really similar to what we just did in the previous two examples, except of course it just looks a little bit trickier for that little formula for length. But now we're going to do this the same way, where since we are dealing with perimeter, we're going to write down the perimeter formula for a rectangle. So P equals 2L plus 2W. And we can go ahead and just substitute in exactly what we're told the perimeter has to be. And then we can also substitute in for L. We know L is 4 plus 4W. And now we just did exactly what we did in the previous two examples. We created a linear equation with one variable, and we solved this the same exact way. So we're going to distribute the 2 on the right-hand side. So we get 8 plus 8W, and then plus the 2W at the end. And then we can subtract this 8 to the left-hand side. So 508 minus 8 is 500. So we're going to get all the constants on the left, all of the variables on the right. 8W plus 2W is 10W. And then divide both sides by 10 to finish solving this for W. 500 divided by 10 gives us 50. So the units of measurement for this one is actually in yards. So just make sure you're labeling it with the correct units of measurements. So this is going to be W is 50 yards. And of course, we're finding all of the dimensions. So we're finding width and length. So length is 4 plus 4 times the width. So that's 4 plus 4 times 50 that we just found for the width. And we can just go ahead and evaluate this. 4 times 50 is 200, plus 4 is 204. So the width is 50 yards, and the length is 204 yards. Okay, so that is it for this section.